Bismillah ar-Rahman ar-Rahim. Good morning, everybody. Our lesson today is chapter 20. Chapter 20. Chapter 20 in page 163. Chapter 20 in page 163. Our lesson today is about useful products from crude oil. Useful products from crude oil. Of course, you know that crude oil is an organic compound. Not organic compound, it is an organic mixture, hydrocarbon mixture. And as I said to you before in the first period, that the term organic give it to all things. They believed that organic things could be produced inside living organism like plant, animal, human, like this. But nowadays or now the word organic used for any compound contain carbon, except the smallest or simplest compound like carbon dioxide, carbon monoxide, and so on. Oil or crude oil need millions of years to produce or to make. Okay, this crude oil comes from where? Comes from the dead plants and animals live in the sea. Dead plants and animals live in the sea. When died, go to the bottom and layer of sediment formed on top of them. Take millions of years to change into this crude oil. The crude oil, as you see in figure 22, is a sticky black liquid. We cannot use it as it is, but we have to make something to get the useful products from this crude oil. Also, you have to know that the crude oil is non-renewable resource. So what I want from you here, I want from you to know that crude oil is non-renewable resource. As you see the highlight, you have to know that the crude oil is a mixture of hydrocarbon, organic hydrocarbon, and you have to know that the term organic now give it to all things contain carbon except the simplest compound. And also I want from you to know that the hydrocarbons found in the beginning, these are the parts you have to highlight. Crude oil is a finite non-renewable resource. And you have to know that's a mixture of hydrocarbons. Contain carbon and hydrogen. I want from you to know that hydrocarbons can occur in or as chain, branched chain, ring like benzene, or combination from ring and branched chain like this, combination between ring and just a chain like this. So hydrocarbons can occur as chain, branched chain, rings, or combination. Okay, this all thing I want from you in this page 163. Okay. Also, I want from you to know what happened or how properties, I'm sorry, how the properties of hydrocarbon change with molecule size. How properties of hydrocarbon change with molecule size. Okay. I want from you to highlight as the molecules, you see here, as the molecules get bigger, what happened? The intermolecular attraction increase. The intermolecular attraction increase. As the molecules get bigger, you have to know these 4 points. Number 1, boiling point increase. Boiling point increases. Number 2, the liquid become less volatile. Less volatile. Number 3, the liquid flow less easily, so become more viscous. Become more viscous. And the last property, bigger hydrocarbons do not burn as easily as smaller ones. So we have to make something to change the bigger molecules into smaller molecules to be able to take the energy inside these molecules. Okay, so in the beginning, I want from you to know what is the crude oil, and it is non-renewable resource. Crude oil is a mixture of hydrocarbon. You have to know that hydrocarbon can be found or occur as chain, branched chain, ring, or combination. And the description of crude oil is sticky black liquid. Now, the properties of the hydrocarbon change when the molecule size change. What are these properties? I want from you to highlight, please, as you see, as the molecules get bigger, the intermolecular attraction increases. As the molecules get bigger, the intermolecular attraction increases. As the molecule get bigger, I want from you to highlight this only. The boiling point increase, the liquid become less volatile, the liquid flow less easily, bigger hydrocarbon do not burn as easily as the smaller ones. Okay, open your book and make highlights, please, as you see. Okay. I said to you, we cannot use the crude oil as it is, as crude oil, but we have to make separation or separating the constituent of crude oil. We describe the crude oil as mixture of hydrocarbon or hydrocarbon mixture. So I want to separate this mixture. I use what? I use fractional distillation. Fractional distillation. Why especially we use this method? Because the constituent of the oil, each one of them has different boiling point from the other. So due to presence of different boiling points. So important. How I can separate the mixture of crude oil? It's mixture. And we know how we can separate mixture by a lot of ways. From these ways, we can use fractional distillation. When I can use fractional distillation? When I have different boiling points. Okay? So the process is called fractional distillation. Important. We use fractional column. We use fractional column. Okay, this is a fractional column, and we put inside it the crude oil and start to give me these products as you see. Please, I want from you to memorize them as it is in order. So what I want from you in this part, I want from you to know that separating crude oil by fractional distillation. Why fractional distillation? Because I have different boiling point for this mixture. Okay, and I use fractional column. Fractional column, as you see here. I said to you, we separate them by using fractional distillation according to the difference in boiling point. The first thing I can get from the fractional fractionating column, refinery gases. Refinery gases. Refinery gases like propane, ethane, methane, like this. Refinery gases like methane, ethane, propane. And then gasoline. We can collect these gases at 40 degrees Celsius. Okay. Then gasoline, which we call it petrol. Kerosene, diesel oil or gas oil, fuel oil. I want from you to know them in order, please. And at 400 degrees Celsius, bitumen, that we use it in making roads. So here I use fractional distillation to get the fractions of the crude oil. The first thing we can get refinery gases. Refinery gases like methane, ethane, propane, like this. These gases. And then gasoline. I want from you to know that gasoline is the most volatile product from the fractions of separating oil. Fractions of crude oil. Gasoline is the most volatile. Then kerosene, that we use it as a fuel for airplane. Diesel oil and the fuel oil is the most viscous. Okay, so I can ask you, these are the fractions of crude oil. Which one is the most volatile? Gasoline. Which one is the most viscous? Fuel oil. And the last one, as you see here, bitumen. Okay, so all things I made highlight over them are important. I want from you to know the uses of these fractions. Important. We give you this lesson to know the uses of these fractions. These fractions, we use them as fuels. Okay. And here it is a repeated information that in case of incomplete combustion, there is production of carbon monoxide, not carbon dioxide. And I explained to you that carbon monoxide is colorless, odorless gas and toxic gas because it combines with the hemoglobin of the blood instead of oxygen. So the amount of oxygen reached to the cells inside the human body will be less or insufficient to make the cells make cellular respiration. Okay. The uses of these fractions are very important. Again, I said gasoline is the most volatile, fuel oil is the most viscous. Here, gasoline. As you see, I made highlight over all fractions, so you have to know the uses of these fractions. In the beginning, we have refinery gases. Refinery gases, it is a mixture of gases like methane, ethane, propane, and butane. Okay? We use them for domestic heating and cooking. So here we have refinery gases, which are a mixture of methane, ethane, butane, like this, and we use them for domestic heating and cooking. For domestic heating and cooking. Important. And then gasoline, which is highly volatile or most volatile. Gasoline, okay, is a mixture of hydrocarbon. You have to know that gasoline is also fuel for cars, for trucks, motorbike, and highly volatile. Kerosene. Kerosene is a fuel for jet aircraft. Kerosene, fuel for jet aircraft. As domestic heat oil and as paraffin for small heater and lamps. Kerosene. Now, gas oil or fuel oil. Diesel oil. Diesel oil. Diesel oil. We use it for buses, lorries, railway engines. And the fuel oils for ships, boiler, and for industrial heating. So, I want from you to memorize the order of these fractions, which come first and which come last. Okay? You have to know that gasoline is the highly volatile, most volatile. Fuel oil is the most viscous. You have to know the uses for each one of them. For each one of them. This is the highlight for this page. You have to know that fuel oil used for ships, boilers, for industrial heating, okay? And example, مثلا refinery gases, we use them for domestic heating. What are the refinery gases? Important to know them. Methane, ethane, butane, like this. Gasoline, we use it as a fuel for cars, for trucks, for motorbikes. Kerosene, we use it as fuel for jet aircraft, domestic heating. Gas oil or diesel oil, we use it for buses, lorries, railway engines, like this. So the uses are very important. Okay. Please make highlight in your book. And then we said in the beginning of the lesson that the large molecules, we cannot get the energy from the large molecules directly. So we have to make something, what we call it cracking. Definition of this term is very important. Definition of this term is very important. What does it mean by cracking? I change or split the large molecules or large molecule of hydrocarbon into small molecules to be able to get the energy inside it. So what does it mean by cracking? Look here, I am in page 166. Open your book, page 166. Cracking. Important definition. Cracking is a useful process in which large hydrocarbon molecules are broken into smaller ones. What is the benefit to break down the large molecules to smaller ones to get the energy inside it. To get the energy inside these large molecules. Because these large molecules, as it is, I can't get the energy inside them. Okay? I want from you to know these two black dots. Very important. Very important part. He said here, although the fraction from crude oil are used as fuel, we have a problem. The amount of each fraction you get will depend on the properties of the various hydrocarbon in the original crude oil. I want from you to know this information, that the fractions depending upon the various kinds of hydrocarbon. And also, apart from burning, the hydrocarbon in crude oil are fairly unreacted. So we use a process called cracking. And you have to know the definition. That is a useful process. Use it to break down the large molecules into small molecules to get the energy from them. Okay? How cracking works? Important to know the condition we use them to make cracking. Look here. The conditions are temperature about 600 to 700 degrees Celsius. It's a higher temperature. And we call this thermal decomposition. Thermal decomposition. Okay, this paragraph is important. The gas oil fraction is heated to give a gas and then passed over a catalyst of mixture of silicon dioxide and aluminum oxide. Important. Important. The condition I use it here, silicon dioxide, aluminum oxide, and temperature about 600 to 700 degrees Celsius. Cracking can be also carried out at higher temperature without a catalyst, but as you know, that catalyst speed up the reaction. What else I want from this chapter? I want to know that if I have something or compound, I want to make cracking for it, you have to get, here I have carbon 13, okay? So, when I count the products here, 2, 3, 6, I have to find them 13. And number of hydrogen 28. When I count the number of hydrogen here, I have to find the 28. Don't forget that if you have a number before the formula, multiply it by the number down. So here, how many carbon? 2 times 2 equal 4. How many hydrogen? 2 times 4 equal 8, like this. Okay? Because may I ask about cracking, about the definition of this term, and give you more than one equation and ask you which one of them represents cracking. Okay, so you have to know the compound here, okay, contain how many carbon atoms, how many hydrogen atoms, and if the products, all the products, when the sum of all the carbons and hydrogen in these products equal the same number of carbon and the hydrogen in the compound undergo cracking, so it will be an equation represents cracking. Okay, this all thing I want from you in chapter 20. It's very easy chapter. I want from you to solve question 1, 2, 3 as homework only. 1, 2, 3 as homework. Thank you. Best wishes.